Hello, this is not your chem tutor, and in this video, I will teach you how to find the empirical formula from combustion analysis. Specifically, we will focus on compounds containing carbon and hydrogen only. So these compounds are what you usually encounter in general chemistry problems and exams. But before you continue this video, make sure you know the basics or you're familiar with the basics of empirical formula. If you still don't know the basics, then don't worry, I made a separate video and you can click the link using in the description box. And as usual, I put examples so we can practice some calculations. Before we proceed with the calculations, let's talk about combustion first. So remember that in chemistry, when we say combustion, that means reaction with oxygen gas or O2. So whenever you have a hydrocarbon, hydrocarbon is another term for compounds containing carbon and hydrogen. So hydrocarbon. So let's say we have CXHY. So a hydrocarbon. So that contains only carbon and hydrogen. If it undergoes complete combustion, so if it reacts completely with oxygen gas, it produces two compounds. First is carbon dioxide or CO2, and the second one is water or H2O. So whenever you have a hydrocarbon plus oxygen gas in complete combustion, it always produces carbon dioxide and water. So as you can see, the carbon in the hydrocarbon is now converted to carbon dioxide. And the hydrogen in the hydrocarbon is now converted to water. So by knowing the amount of carbon dioxide and water produced in the reaction, you will be able to identify the empirical formula. And you will clearly see this in our succeeding examples. Okay? Let's start with example 1. A compound containing only C and H was combusted, yielding 0.69 grams of carbon dioxide and 0.56 grams of water. What is the compound's empirical formula? The molar masses of carbon dioxide and water are also provided in the problem. So let's solve this problem step by step. I just want to say that in order for you to solve this problem, you must be familiar with mole concept. If you're still not familiar with what mole concept is, then don't worry. You can check out my video. I made a separate video about mole concept. You can click the link in the description box. So step 1, find the moles of carbon from carbon dioxide. So in this problem, we are given 0.69 grams of carbon dioxide. The first thing you need to do is to convert grams of carbon dioxide into moles of carbon dioxide using the molar mass. So we are given the molar mass of carbon dioxide in the problem. So 1 mole of carbon dioxide is equivalent to 44.01 grams of carbon dioxide. So the grams of carbon dioxide cancels out, and this leaves you the moles of carbon dioxide. But remember, what we need is the moles of carbon. So we will convert moles of carbon dioxide into moles of carbon. And just by looking at the chemical formula of carbon dioxide, CO2, that means for every 1 mole of carbon dioxide, there is 1 mole of carbon. So the moles of carbon dioxide cancels out, and this gives you, and if you solve this in your calculator, you will get 0.0156 moles of carbon. Now that's for step 1. Let's proceed to step number 2. Find the moles of hydrogen from water. So in this problem, we are given 0.56 grams of water. So again, we need to use the molar mass of water to convert grams of water into moles of water. 1 mole of water is equivalent to 18.016 grams of water. So grams of water cancels out, and this leaves you with moles of water. Now, from water, we need to get hydrogen. So just by looking at the formula, 1 mole of H2O contains 2 moles of hydrogen because it's H2O. So 1 mole of water has 2 moles of hydrogen. So the moles of water will cancel out, and this leaves you the moles of hydrogen. And if you solve this in your calculator, you will get 0.0622 moles of hydrogen. So that's for step number 2. Now let's proceed to step number 3. Put the moles as the subscript of the element. So we have carbon and hydrogen. So from step number 1, we did earlier, we got 0.0156 moles for carbon. So you put that as the subscript of carbon. And we got 0.0622 moles of hydrogen. So you put that as the subscript of hydrogen. So that's step number 3. For step number 4, you pick the smallest subscript. So between the two, the smallest is 0.0156. Divide all the subscripts by that number. So let's just rewrite H 0.0622. The smaller number is 0.0156. You divide all the subscripts by that number. So 0.0156 divided by 0.0156, that's obviously 1. So C subscript 1. 0.0622 divided by 0.0156, that's approximately equal to 2. To 4. So C1H4. But remember in chemistry, when the subscript is 1, we omit it or we drop the subscript. So this simply becomes CH4. So the empirical formula and the answer to example 1 is CH4. Now let's try example 2. You can actually pause the video, solve this first on your own, and then come back to check your answer. Okay, so a compound containing only carbon and hydrogen was combusted, yielding 17.6 grams of carbon dioxide and 7.2 grams of water. What is the compound's empirical formula? So again, step 1 is to find the moles of carbon from carbon dioxide. So we are given 17.6 grams of carbon dioxide. So we use the molar mass given to convert grams of carbon dioxide into moles of carbon dioxide. So 1 mole of carbon dioxide is equivalent to 44.01 grams of carbon dioxide. By the way, these molar masses of carbon dioxide and water that is shown on the screen, you can actually solve them on your own using the periodic table. So I'm pretty sure you already know by now how to solve the molar masses of compounds, right? Okay, so the grams of carbon dioxide will cancel. And then the next step is to convert moles of carbon dioxide into moles of carbon. So 1 mole of carbon dioxide contains 1 mole of carbon. So the moles of carbon dioxide will cancel out. And if you solve this in your calculator, you will get approximately 0.4 moles of carbon. So moving on to step number 2, we are given 7.2 grams of H2O. We are given the molar mass of water. 1 mole of water is equivalent to 18.016 grams of water. So grams of water cancels out. And then 1 mole of water has 2 moles of hydrogen. So the moles of H2O cancels, and this gives you moles of hydrogen. And if you solve this, this is approximately 0.8 moles of hydrogen. For step number 3, we put the moles as the subscript of the element. So for carbon, we got 0.4 moles, and for hydrogen, we got 0.8 moles. So let's just copy that one. Carbon 0.4, hydrogen 0.8. You pick the smaller subscript, so the smaller subscript is obviously 0.4, and you divide all the subscripts by that number. So for carbon, 0.4 divided by 0.4 is 1. For hydrogen, 0.8 divided by 0.4 is 2. So again, whenever the subscript is 1, you drop the subscript, and this simply becomes CH2. So the empirical formula and the answer to example 2 is CH2.